Professor Proton. Can we all say my name together? Professor Proton, and I am a nutty scientist. Are you guys excited about today? Because I am going to show you something very special. Now, how many of you like magic? You like magic? Me too, I love magic. But you know what? I also like science. And sometimes with science, you can't really tell if it's science or if it's magic. So today, I'm going to be showing you something, and you guys will have to tell me if you think it's magic or science. Are you guys ready? Let's start. All right, I have this cup, and I have a question for you guys. What would happen if I let go of this cup? Do you think it's gonna fall down or do you think it's gonna fly up? Let's test it. I guess it fell down. Why do you think it fell down? That's right, because of the force called gravity. You guys are so smart. Now, let's try something else. I have this metal tray, and what I'm going to do is I'm gonna put this cup, and it's just a regular plastic cup. I'm gonna put it on the tray, and I'm gonna turn the tray upside down. What do you guys think is gonna happen? What about gravity? Oh, you think it's gonna fly? You think it's gonna fall? Let's test it. Are you guys ready? I guess it fell again. So here's my question for you. Do you think it's possible to turn the tray upside down and for the cup to stay inside the tray? What do you guys think? No, you cannot use magnets. So smart. You cannot use magnets, you cannot use tape, you cannot use glue. Let's try it. Are you guys ready? I'm going to hold the tray by the string that I have over here. And, you guys ready? And 1, and 2, and 3. Did I just turn the tray upside down? How did the cup stay? Do you think this is magic or do you think this is science? That's right, this is science. Because you see, there is another force, and it's called Centripetal Force. And that's the force that held the cup in place when we rotated the tray. But you know what? Let's make it harder. Instead of 1 cup, let's put 4 cups. Do you think it's still gonna work? Do you think gravity will win? Or do you think centripetal force will win? Do you think the cups will stay on the tray? Or do you think they will fall down? Let's try. 1, and 2, and 3. I guess centripetal force won, and our cups still stay on the tray. But let's make it even harder. Are you ready to make it even harder? I am going to add water to the cups. Okay, you guys ready? Make sure I'm pouring. Am I pouring? Let's make sure I'm pouring. Let's get a little bit of water into each of the cups. I'm trying not to pour all over myself, but hey, I'm clumsy. Okay, are you guys ready? Now, what do you think? Will the cups stay in the tray and water stay in the cups? Or will Professor Proton give herself a shower? Let's try it. Okay, get ready. Gonna hold it. Whew. Guys ready? And 1, and 2, and 3. And 1, and 2, and 3. And was it magic or was it science? That was science. Our water, which is still in the cups, stayed in the cups, and our cups stayed in the tray because of the force called centripetal force. Great job, guys! Okay, guys, are you ready for the next experiment? Remember, you have to decide if it's magic or if it's science. I have a hairdryer, just the same one that you have at home, and I have a ping pong ball. Is there a way for me to make the ping pong ball stay in the air? How about by using hairdryer? Let's turn it on. Let's put it on top. Oh my goodness! But how about I move around myself? Is it magic? Or is it science? How is the ping pong ball staying in the air and how it follows me? I think I got myself a pet ping pong ball. What do you guys think? Guess what? Some of you will learn it many years from now in high school, but this is called Bernoulli's principle, and whenever air is coming out really fast, the area inside becomes area of low pressure, and then the air all around it is the area of high pressure, and so the area of high pressure keeps whatever is inside the area of low pressure sitting right in there, and so our ping pong ball is kind of stuck inside of that area of low pressure. Let's do it one more time. And it stays with me. And now that I have my ping pong ball, how about we try something else? I'm going to put my ping pong ball on top of this glass container. Anybody knows how we call this glass container? Nobody? Okay, I'm gonna make it easy for you. Is this a flask? Or is this a pink elephant? Of course it is a flask. You guys are so smart. Okay, I'm going to put my ping pong ball on top of the flask. And I have a question for you. What would happen if I lift up the flask and turn it upside down? What do you guys think? Ooh, I hear the word gravity again. You think the ball will fall down? Let's try it. It did fall down. Interesting. Okay. Is there a way to lift up the flask and for the ball to stay on top of the flask without falling down? Do you think it would be magic? Or do you think it's going to be science? Let's try. And for this, I actually need water. I'm going to pour water into the flask. And what I'm going to do, I'm going to pour as much as possible when water is pretty much overflowing. Okay, now I'm going to put my ping pong ball right on top. Perfect. And now I'm going to lift up the flask and I'm going to turn it upside down. Are you guys ready? Is it magic or is it science? I know it looks like magic, but this is actually science. And the reason for it is because the air pressure all around the ping pong ball is higher than the pressure of the water inside the flask. And so when we turn it upside down, air is actually holding the ping pong ball stuck. This is all science. Okay, now we're gonna do something very interesting. I have 6 cups and I also have these 2 special liquids, and what I'm going to do, I'm going to pour a little bit of the first liquid into each of the cups. Let's see what happens. And I'm gonna only pour tiny bit. I guess nothing is happening yet. Okay, let's continue pouring. And I'm going to stir inside of the cup so you guys can see. Alright, now let's add the second liquid and see what happens. Oh my goodness! It just turned red! Wait. Wait. I think this is turning orange. What about this one? No way! This is yellow! I wonder which color we're gonna get in this cup. Ah, this is green. What about this one? Blue! What about this one? Purple! Oh wow! We have just made ourselves a rainbow! Oh, this is amazing! But you know what? Wouldn't it be exciting if we could actually mix those colors together? Maybe then we can get the real rainbow? I have an idea. Let's use this. Remember how we call it? That's right, Flask. Let's use this flask to mix all the colors together. Okay? Let's do this. I'm gonna move cups out of the way. And I'm going to have my flask right here in the middle. Okay, you guys ready? I'm going to pour half of each cup into the flask. But wait! Where is my color? My color is disappearing. Where is our rainbow? I thought we were making a rainbow. Let's add some yellow to it. Oh no. Well, I'm sure those darker colors are definitely gonna work. How about green? No, green disappeared as well. What about our blue? Oh, and blue is gone. How about purple? Oh no, look at this. Where is our rainbow? Oh, I have an idea. How about we pour from this flask back into the cups? Maybe then we can get our colors back. Are you guys ready? Oh my goodness, what's happening? I think we just lost all of our colors. What do you guys think? Do you think this was magic? Or do you think this was science? I know it looked like magic, but you know what? It is actually science, and it has to do with acids and bases. Good job, guys! And for my final experiment, we are actually heading outside. I'll see you there. Alright guys, are you ready for our last experiment of the day? And I bet you already know what we're gonna be doing. I have a lot of chemicals here, and the first one is called hydrogen peroxide. And some of you probably have hydrogen peroxide at your home, but the one that you have is 3%, and this one is 30%. That means that it's very, very dangerous. If it gets on my hands, it is going to burn my hands, and that's why I'm wearing my gloves and I'm wearing my goggles. So let's add 100 milliliters of hydrogen peroxide. We're gonna add it to the flask. Perfect. All right, next we are going to add some soap, and we only need a little bit. So let's add just about 10 milliliters of soap. And last but not least, we are adding potassium iodide. Guys, ready? Oh, that's too much. Okay. And now you guys need to give me a countdown. 3, 2, 1. Oh, wow! What did we make? Did you say volcano? That's right. We've made a volcano, but we didn't just make a volcano. We've made a chemical reaction. Can you do it with me? Chemical reaction. We've mixed all of those liquids, and we got something that wasn't there before. We made a gas, and that's why it kind of jumped out of our flask. And that gas is called oxygen. Wow, look at this massive, massive marshmallow. Oh, I'm sorry, volcano. Isn't science amazing? Do you guys think this was magic or do you think it was science? That's right, it was science. And that's it for today. I hope you guys are gonna do lots of science experiments at home. And I will see you soon. Bye!